part 2. Okay, sorry about that. I'll try to be as short-winded as possible. Okay, we were talking about central angles. Okay, so we have 2 types of angles to look at today. One's called the central angle, and the other one's called the inscribed angle. Okay, a central angle is exactly what it sounds like. The vertex or the point of it is at the center of the circle. Okay, that's just a central angle. Very, very simple. Inscribed has its vertex on the circle. Okay, this one can be a little bit confusing. So I always go back and say, where is the vertex? Where is the vertex? If you just look where the vertex is, you got your angles right. So central angle has the vertex at the center. And now let's look at an inscribed angle. So let's say that this is point A, B on circle Q. Circle Q because Q is in the middle. Okay, if I want to draw an inscribed angle with A and B's arc, I could go down here and put that vertex down there on the circle, and then I would go up and put my end point up there at B. So this is an inscribed angle because the vertex is on the circle. So let's draw a couple real quick. Okay, first one's right here. Here's my circle. Here's my angle. Here's my circle. And here's my angle. Okay, this is circle A. This is circle B. Circle A, what kind of angle is that? Circle B, which kind of angle is this? I hope you said inscribed, and I hope you said central. Vertex is at the center. Vertex is on the circle. And here is our arc right here. Vertex is at the center, and the angle is right here. There we go. That's inscribed and central angles. And that's the end of lesson 1. That's all of lesson 1. So let's jump over to lesson 2. Lesson 2. Try to keep this short and sweet. We now are going to throw some formulas and some angle measures in. So let's go over a couple things. How many degrees are in a circle? Hopefully you already have that answer. It is, all the way around, 360 degrees in a circle. So if I draw in a diameter, the top semicircle is 180 degrees. The bottom is 180 degrees. Those are semicircles. Now, let's look at circumference. Circumference is equal to, there are 2 formulas you can use. Either d pi, which is the one I like because it's easy just to plug in a d, or 2 pi r. Well, 2 radius equal the diameter, so all you're doing there is substituting. Okay, so that's how you find the circumference of a circle. And so let's say that our radius is 4. What is our circumference? Well, 2 pi times 4, or multiply that together, 8 pi. Why I prefer the diameter is I like to go ahead and say, okay, if my radius is 4, my diameter is 8, and then I just plug in 8 pi, and I'm done. So you can do it that way if you want to. Okay, now let's talk about arc measures. So that's circumference, and that is hopefully, we'll just review. Okay, now let's look at the angle measures. Okay, central versus inscribed. A second ago, I just went over central angles. Central angle has the vertex at the center. Okay, the actual measure of this arc or angle is going to be equal to the measure of the arc also. So if this is a 40-degree angle, this arc measures 40 degrees also. It's really simple, same as a central angle. Okay, so if this arc is 40 degrees and that's a minor arc, what is the major arc? Out here. So in other words, what's the rest of the circle? 360 in the whole thing. I'm going to take away that little minor arc. I'm going to take away the 40, and I'm going to get 320. So that means this major arc is 320 degrees. So we just subtract it. Okay? So far, so good. Now, let's look at how you find arc length. Okay, so we're going to kind of put two things together now. We're going to take circumference, we're going to take angle measure, and put it together to find arc length. Okay, let's draw it up here. This is our formula that we're learning in this lesson. Okay, let's say that we have a 90-degree angle here. 90 degrees, so we have a right angle. And we're trying to find out how long is this arc. Okay, that's different than the actual measure of the arc. Okay, the measure is 90 degrees, but that doesn't tell us how long the arc is. Okay, let's say we've got to know the radius. So let's say the radius is 4. Okay, well, we could figure out the whole circumference or the whole length of the arc by just doing the circumference formula. Circumference equals d times pi. So diameter is 8, so that's 8 pi. But this is not the whole circle, is it? It's only part of it. We want to know just this arc length. So if the whole circumference is 8 pi, what fraction do we have? What part of the circle do we have? Which part of the pizza crust are we going to eat? We're not going to eat the whole pizza, only a fraction of it. Well, it's 1/4 of it, isn't it? Well, where are we getting a fourth? 360 degrees divided by 90 is 4. So it's a fourth of the circle. Okay? Now, that's not the actual formula, but I just wanted to see it's 4 equal parts. So this is 1/4 of the circle. So I can take pi, or 8 pi, which is the whole circumference, and I'm going to multiply it by 1/4. Well, the easy way to get that fraction is to do 90, which is the angle measure here, over 360, which is the whole circle. So we're going to take our measure over 360. So I'm going to reduce this. So 8 pi over 1, because we always put a whole number over 1. I'm going to reduce this to the 1/4, because it's 1/4 of the circle. Multiply straight across 8 pi over 4, which is 2 pi. So there we go. That's my arc length, 2 pi, because it's a fourth of 8 pi. And that's how you do it, okay? Let's look at one more of those. And I'll show you how the formula works. The formula is very simple. For arc length, here we go. We are going to take circumference times the measure over 360. That's all there is to it. So circumference is, we got to have a length here. Let's say the radius is 10. The angle is 120. And we're trying to find the arc length from A to B. How long is that arc? All we do is plug in. Circumference is diameter times pi times the measure over 360. Okay, what is our diameter? Well, radius is 10, diameter is 20. 20 pi times 120 is our arc measure over 360. So what fraction of the circle is that? 1/3. So 20 pi times 1/3 is 20 pi thirds, and we are done. And that's how you find arc length.